Hello again, thank you for coming and or staying. Right now we're going to have a presentation by an international company that's involved in several Hyperloop things, and they're also a sponsor of the European Hyperloop Week. Let's give a warm welcome to Carolina, Kawar, Michelle and Walter from AECOM. Thank you.
Thank you, Laura, for the introduction, and indeed happy to be here, happy to be back on stage after quite a long while where it was not allowed to. Yeah, like Laura said, we as AECOM, but also especially we as Jury Group 8 would like to present our thoughts about Hyperloop today. We have Kawar online, so hopefully he can hear us. Kawar, can you wave? Good, that's good that all the techniques work. Yeah, like visible on the screen, we will start with a short introduction. Then we will tell a little bit more about ourselves, our companies, because we are actually already a connection made by European Hyperloop Week, which is a success in itself from that aspect, I would say. Then actually Kawar will tell more about the preliminary feasibility study he did within AECOM for the Canadian government. Then Michele will go into actually the real topic of today, the homologation, standardization and harmonization. And at the end, Carolina and myself will be here to have a discussion with all of you. So we like you to be here, to speak up, share your thoughts, because in the end, that's where we are here. Sharing knowledge, making sure that next year we're getting a little bit closer to the point where Hyperloop is really there in the outside world. Yeah, as an introduction, I like to share a post of Reinier van Landschot, and I think the Dutch people over here have maybe seen it actually on LinkedIn. It's not about Reinier, it's about actually a statement that he made. And he reminded us that about 2 years ago, and then again 50 years earlier, Mr. Gagarin was on the moon. And I think that's really something inspiring, but it also inspired us to think about what can we do with Hyperloop. And if you combine that with something that is happening at the moment, a European Union spending massive amounts of money, 750 billion, on recovery plans, what would happen if we would spend that amount of money, not like he suggests on high-speed rail, but on Hyperloop? What would happen at that moment? And actually, are we ready for it? Are we ready to spend so much amount of money on Hyperloop? And how much kilometer can we actually build with this amount? Would we cover all over Europe? How much efforts have to be made to get to CO2 neutral Hyperloop? And not only considering, of course, when you use renewable energies, but also thinking about building actually the Hyperloop, the materials that we use, the type of levitation, etc. Will passengers use the Hyperloop, or will they prefer, like actually happened 100 years ago, the old conservative systems that they know already before they step into something new? Do they dare to step in? And what actually then needs to happen to get Hyperloop constructed? Now I'd like to hand over to Michele,
thank you.
Telling a little bit about his company, Molinari.
Thank you very much. I'm very happy to be here, and first of all, I would like to congratulate all participants. I'm smitten by this passion, by what has been presented today and what I have seen over in the hall. And I can only congratulate you for participating during your studies in such a team, in such a event, and to try to give your best. Please take this with you into the future. So who is Molinari? Molinari Rail is a Swiss engineering group, and we focus on mobility and especially on railways. We are engineers in the pure sense. We develop solutions for the railways, and we implement them as well. And we are based in Switzerland, Austria, Germany, and from there we go just around the world. How do we get forward? Ah, you have it. Good. Our focus is of course, on problems which our customers have daily. But we look forward also to, for example, develop hydrogen trains, hydrogen train operations in Austria, for example, and with the aim to lower emissions and to develop solutions for the future in the railway, for the maintenance, for the operation, for cargo solutions as well. A little bit. Now I know why. Maybe some little anecdote. The first time I was exposed to Hyperloop similar project was in 1993-94 at my first job. In Switzerland, there was an idea, a proposal for the Swiss metro to build an underground tube with vacuum and connect the major cities in Switzerland and have it go through just a few minutes from one side to the other. So if you want to go and see a little bit older ideas, this is one place to go, Swiss metro. So thank you very much, and I will hand over to Carolina.
Hi, hello. My name is Carolina Trzycka, and just, I think, 4 years ago, I was exactly in your shoes. I used to be on the commercial side of Hyped 4 years ago, and today I'm here representing Lens Labs, which is a startup in Edinburgh, and we share still quite a bit in common with you. We all met at the occasion of working on Hyperloop, but we were arguably even more impatient, and we loved the technologies behind Hyperloop, but we wanted to see them implemented even faster. And so while actually working after Hyperloop, we decided to apply the principles of electromagnetism that we had discovered and understood through our SpaceX competitions participation, and apply to the very real problem of rail lines in the UK and abroad. Anyone will know that delays are absolutely terrible anywhere, probably, and especially so during winter. And so we decided to address this problem and essentially target a close to £400 million opportunity. And we do that with an integrated hardware and software design, where we kind of apply, we have a bolt-on device that gets onto the locomotive wheels and aims to add traction and solve the problem of low adhesion, as well as actually sensing what's happening at the wheel track interface, fundamentally making it a sort of smart winter wheel for existing and very much loved railways while we're waiting for you to build the actual Hyperloop. So very glad to be here.
Carolina, and yes, as maybe already known, I'm from AECOM. AECOM is a company that operates worldwide as a consultant engineering firm. If you look us up on the internet, you actually get into this page, and yeah, we are about 47,000 people worldwide, like I said, globally active in all 7 continents. Yeah, really glad as a company to be connected to Hyperloop. We see that there's a lot of potential, and yeah, we want to keep up with the latest technology, making sure that we are the world trusted infrastructure consulting firm in all directions. Yeah, like you see today, we partner with other teams, just making sure that we keep this connection. AECOM cannot do things on their own, we are advising, we're not the technology provider. So we're really interested in all kind of options actually that you and the startups have seen over the last years around Hyperloop. This is a short movie about our company. Oh. question is okay. And I think, like also Michele said, I think it's something really nice to be here. It's something to be proud of, and I really encourage you to tell the story to your follow-up student colleagues and make sure that this kind of events like European Hyperloop Week will continue in the next week with support of the bigger companies. Now, as a team, and this is not only AECOM, this is also the jury group, we have really one common purpose actually, and that's like yourself, building a sustainable and better world and making sure that Hyperloop will succeed and contribute to that. Good. Kwar, then I'd like to go to you. If you just give me a signal, I will try to get to the next slide. You're there?
Yep, can you hear me?
I hear you loud and clear. Thank you.
Okay, thank you, Uta. And I'd like to just give you a short introduction about myself. So my name is Kawa Ashraf. I'm a director of transportation planning engineering. I've had a very long, full career, over 20 years. Started back in the UK, Scotland, moved down to England, worked on many different levels of rapid transit, moved to Canada in 2010, and I've had the privilege to work on a diverse, projects, infrastructure projects. And today I really want to kind of talk to you about one of the jobs I'm very proud of, and is very cutting for our federal government, Transport Canada. So to kind of kick us off, just want to say thank you to the organisers, European Hyperloop Week, for having me today and let me having a chat about this particular topic, and also to the team for all the hard work that they've been putting into this. So just to kind of give us a baseline, I want to start off with just explaining for all of us, I think, what Hyperloop means and some of the key features. So Hyperloop is a low pressure environment in a tube would reduce friction, potentially allowing pods to travel up to 1,200 kilometers per hour. These pods or capsules would float within a tube using either magnetic levitation or some sort of air cushioning. New routes could be developed to offer fast links between major cities and metropolitan areas. So they're really in the realm of rivaling air travel. The tubes would either be elevated to reduce footprint and improve resilience, or tunneled underground in a more densely populated areas. So next slide, Uta. So what is the study? So Transport Canada contracted AECOM to appraise and review two principal considerations concerning the evolutionary development of Hyperloop technology. And I was going to take a few minutes just to read these out, because I think these are quite important. So can Hyperloop concept be transformed into a viable technology that is safe for passengers and communities where the tubes traverse? And secondly, is the Hyperloop technology cost significantly more affordable than, or at least comparable to, conventional high-speed rail systems or developing magnet technologies? So many of these systems and other elements exist. So we were placed with a very difficult number of questions with a lot of moving parts and quite complex. And I'm not going to go through every component. Maybe next slide, Uta. I'm not going to go through each of them, but I'm going to give you a high-level overview of two of these main parts. So the first, what we looked at was to develop an understanding. So this is to look at progress to date. So this is March of 2020 on the Hyperloop concept through a thorough literature review of the technology and initiatives that were conducted to date. Secondly, to understand the various engineering concepts and design, an independent review of the technology was conducted by a multidisciplinary team at AECOM and with some specialized sub-consultants, which included a series of technology readiness level assessments. Thirdly, to inform our readiness of the technology for application in Canadian context, a hazard and risk assessment was conducted with the resultant risk compared to those extent in other transportation modes and discussed to provide an examination of how they could be mitigated. And finally, we took a very high level review overview of the technology and a preliminary high-level cost for capital and operating and performance, which included the comparison of Hyperloop technology as a new mode compared to existing transportation modes. So just next slide. So a quick overview of the engineering design. So during the course of the study, AECOM assessed a combination of public available literature, consulted with internal and external Hyperloop experts. So these are experts from around the globe, drawing on all the experience. We interviewed leading Hyperloop technology developers. As the published literature on Hyperloop is limited in both quantity and independency perspective, we conducted interviews of the various developers to gain a better insight into the technology challenges as well as at least the design considerations. Next slide. So Hyperloop concept as an engineering. We assessed whether the initial claims made by the performers of the technology are credible and to establish which elements of the system needed further refinement. So listed out here are some of those findings, and we performed an assessment. So next slide. So to kind of keep this independent and neutral, what we had adopted was the established NASA technology readiness levels. These are the TRL framework and criteria was used to examine the technology components in a framework format. Given the high variance and the number of multiple elements and the complex combinations in systems, the TRL assessment focused on those major components and technology elements that are potentially common building blocks of a Hyperloop system. So, I'll refer back to the word common, that are consistent across the board. And I think we're going to cover some of these discussion elements in our next presentation. So the estimated TRL reflects the tangible analysis, defendable data, and reliable and credible documentation to reflect those. So in a summary, this is a difference of opinion amongst Hyperloop developers regarding key statistics. For example, the average vehicle mass of a capsule, is approximately 20 tons based on a 47 passenger carrying capacity. However, the actual pod weight varies significantly between different designs. The estimated headways we found being discussed vary between around low 18 seconds to several minutes, with an average of these being around 120 seconds. Equally, Hyperloop developers have estimated the average system could transport as many as 6,500 passengers per hour, depending on pod capacity, depending on headway. However, with significant differences between the developers and pod capacity, the hourly capacity ranges quite significantly. On average, the maximum operational speed we found is stated in the region of 1,000 to 1,200 kilometers per hour. Again, this is subject to many other elements that are linked to this, including switching, including power supply, including the type of technology you would use to slow down, speed up the actual capsules. The Hyperloop tube, in general, will be made of steel and would measure between 3 and 5 meters in diameter. And just to summarize at the bottom of that previous slide, the bottom left-hand corner is how we rated, based on our professional opinion and subject matter experts, the level of readiness for that for each part of that technology and where work is still to be undertaken. And again, this is there to kind of help inform and allow things to progress as they move on. Okay, next slide. I'm just going to cover two parts. One is from a passenger perspective, and the second will be from a freight perspective. So from a passenger perspective, the concept of Hyperloop was first conceived as an alternative to high-speed rail, specifically to provide a connection between San Francisco and Los Angeles for passengers. Although concerns remain about the system operation and the ability of a human body to handle such conditions, the target market for Hyperloop is still envisioned to have passengers or commuters several transportation modes offering different travel experience already exist, each with its own benefits. And I've just shared a few of those travel experiences that Hyperloop in comparison to others. Next slide. So from a freight perspective, there is a growing interest in the use of Hyperloop for freight, given that fewer challenges are anticipated in achieving operational readiness. In these short timescales for approval of freight are realized, a situation where the early adopters of Hyperloop use the route exclusive of freight is conceivable, providing the opportunity to deploy and operate technology while any understanding requirements for passenger transport are resolved. Although freight market for Hyperloop is still in its infancy, several possible applications have been considered. However, the limitation to size, weight, load, and design of a pod are likely to impact the types of cargo that can be transported. Next slide. So just to kind of close off, here is a summary of some of the governance and guidance that we looked at, and how complex and overlaid and interdependencies exist. So this really identifies from an external body might provide insights to mitigate or remove risk. So one of the things that an agency like Transport Canada might be responsible for interacting from a governance point of view. It is expected that other agencies will be involved in this process, similar to the aviation, to bring some standardization and to bring some continuities between the various things. The list shown here is not extensive, but it's the current state of Hyperloop technology as it develops, meaning that the changes in time will help to streamline and improve each element. Thank you. Over to you, Wouter.
Thank you, Kawar. I think good summary. And when reading as a jury group through all the submissions, and I would say the extensive submissions, we've seen that some of you have found actually this report already. It's freely available on the internet, and we will share the link later, because we believe it's important to keep sharing and building together on improving Hyperloop. I'd like to give the word to you, Michele, going into the topic of standardization, harmonization, and homologation, because we believe that as a jury group, seeing what we have received from everybody, knowing where we are as Hyperloop worldwide, there is a next step to be made. And we foresee that actually this is a very important next step, just making sure that we get at some point to one system going forward.
Thank you very much. I can only recommend to read the AECOM report done. It's very, very good and informative report. You can learn a lot about this. Of course, the idea is the question is how to bring it from the drawing boards and from the research and university style into the real life. To do that, we have a few key aspects, of course, to take into account. The most we have seen already. I don't want to repeat them. That does not make any sense. You can see them there. Has been explained very well before. A few key points, of course, from the technology bring us to the standardization and then to the homologation. And the question is, of course, why do we need to have this discussion? On one side, the question is, what is a Hyperloop system? Is it to be seen as an airplane, or like a bullet train, or like a maglev? I personally think it is a combination of all. Depending then on how you look at it, it has something more of a train to be considered with regard to standards, or in certain parts it is definitely like an airplane. And the question, of course, is also there, why does this come up with this standardization, harmonization, and homologation? This is part of my job, or the job of many people at Molinari, to think about this. when we design trains and other stuff. In the first place, it is to ensure product safety, that it is safe to use it, for a passenger to board, for an operator to use it and to work on it, and for somebody to live nearby. These are basic questions which over the time since we use technical products have been raised with good and bad results sometimes. And we want to make sure that we can safely transport people. It is safe to operate, it is safe as a product, and it is conform not only at prototype level, but also in mass production, in serial production. Therefore, norms have been developed, the safety bodies, etc. And there are different authorities who are dedicated to this job. Of course, there are European ones, there are American ones, there are worldwide. In every country there are some with regard to aviation safety, railway safety, the European Union Agency for Railway. For the maglev, there is no body defined for that. There is no homologation being done before. There is just, let's say, the test facility in Germany. And for the Hyperloop, this has not yet been defined. The question could be now why it is important. The motto of the week is that the future is our present. So the idea is, and my hope is, that you, and hopefully I can help a little bit still, and we will see it, that this will become reality. And in order to become, the Hyperloop become operational, a commercial reality for everybody to board, it starts to become slowly necessary to think about this. Not only at the government level, but also that the students who will further on be engineers, economists, etc., know what is coming then after in the implementation. And maybe this is a topic which could be taken on also as part of the European Hyperloop Week. What I have here is to show you a little bit how it is done, for example, in the railway. Aviation is more or less similar, and of course it has differences. I know this best. So you have on top the European Railway Agency, which governs this as a supranational body, and then we have the NSAs, which are the national safety authorities. Before, let's say, till a few years ago, the NSAs were running this and then coordinating between themselves. Now there has been created the ERA, which covers this at the European level. The company which, like us, we are right now developing and producing new sleeping coaches for the Austrian Railway, and they will come to Amsterdam soon. And of course, in order for you guys hopefully boarding this kind of coach to go to Vienna, Zurich, wherever, we need to get the permit. So we, for the customer, apply, and each company has to go through a very long, expensive process to show and that the product is safe and follows the regulations. For this, let me see here. On one side, expert reviewers will check very specific characteristics like the running dynamics, the brakes, the crash, fire protection, etc. Then there are, of course, a so-called notified body who define these specifications, especially also for interoperability. This is also something which has been raised with regard to Hyperloop. So assuming there will be different kind of producers and suppliers to make sure that this then all fits together. And then, of course, we have national technical regulations to make sure, because we have still differences between the different nations in the European Union with regard to some very specific rules and regulations. And we know that very well in railway how this goes. And then there are independent assessors which, with the methods which have been also explained before, check what is being proposed. And the company has to show that it adheres and follows these things. This is for you to have a little insight of how this is done. This takes time. First of all, because there is a preparation, applications, etc. And during the development and engineering, a mass of documents has to be prepared to be then submitted to the different experts for review, like here in this part. They will review whatever is being written, if it is conforming to the standards, norms and regulations, and then it goes through the different agencies, and only when all this is met to the very last question and no doubts are there anymore, the homologation is being granted. And this is a very administrative, bureaucratic thing. This is not always fun, believe me. And I'm an engineer, I'm not a bureaucrat, so I have no fun in such stuff. But as an engineer, it is necessary to be able that the product fits and goes through this. So what is shown here with 1 year and 4 months as a minimal basic process time can be much longer if there are too many questions and too many loops have to be done. And this, for example, especially in the railway market, leads to delays and cost overruns. So this is something which happens in real life and has to be taken into account. And for the Hyperloop, this is still yet to come and to be proven. There is a lot of text, sorry for this. It's something just in a short resume is what has been said already today and on Monday. It is necessary that the industry, the different stakeholders work together to make this happen for the Hyperloop, to develop the common standards and the common view how to make this happen. I just go through here what maybe a little bit repeating, the Senelec committee, which has been presented on Monday, and in the Celeros presentation this morning was already mentioned as well. In the US, there is a separate approach, and privates like TÜV Süd from Munich are working on these topics as well. And this is very good. It shows that there is a lot of interest in these Hyperloop initiatives, and there is transatlantic cooperation in this, and also Canada. I'm sure our friend from Canada can agree to that. And I think that's very positive for this new technology which will emerge. but we can do it only in a reasonable time by adopting a collaborative approach. This is just for your information how the TÜV Süd, for example, proposed how to do it, similar to the other approach which we are using already. TÜV Süd, for example, works with us on railway projects, so it's very similar. Risk reviews, risk assessments, inspections during manufacturing and production, and then final certification. And this is not the end. This continues throughout the life cycle of this product. Whenever there are modifications, they have to be reviewed if the product or a single piece or the complete system still meets the standards. And this has to be proven, and only then it can be implemented. Just a few norms which are important in this part. We have railway norms, we have some out of aviation, they are regarding fatigue, fire, very important issue, etc. Just for give you a little bit the flower of what is behind there. And yeah, to get there and to get it done, testing and validation is very important. Celeros, for example, this morning, for those who saw it, presented such a step-by-step approach with the test benches, which are also here at UPV, or then this different kind of test tracks. I think that's a very good approach. It's necessary to reach this goal. And with that, I have come to the conclusion. The aim was not to scare you, it's just to show you what is going on and come. And as I said, maybe this will become part of one of the topics which can be covered in this kind of events. Thank you very much.
Thank you, Michele. And I think really, maybe not the most sexy topic, but really an important topic to get to the next step. Yeah, next step in this presentation is about what's next, and I'd like to invite Carolina on the stage. And I also would like to have you all sitting and standing a little bit to get more energy in the room, but also to make sure that you're involved. To get to that point, we have posted actually some topics, and I would like to invite Carolina to start with the first one.
So thinking about what's happening after the conference, after today, and after the week after you come back, what really is the future? We've seen a departure of the main driver, I guess, of Hyperloop competition, SpaceX, off from the stage. It is immense credit has to be given to the organizers, and I think all of the judges from this group and all of the other groups will say, just recognize how much work you guys have put to make this a reality. It's absolutely immense that you've actually kept the fire Hyperloop going on your own efforts with the pandemic going, and it's absolutely deserving of immense respect, so thank you very much. But the question is indeed asked, what next? Is it a European Hyperloop week annually? Or are we also going to do it in parallel with, for example, the boring competition, since the conversation seems to be moving also around delivering the infrastructure and the technology needed to build Hyperloop, i.e. faster tunneling. What's next?
This event should be organized on a yearly basis. Maria, you do the counting above? Okay. Good knowledge, good insights. Next one.
The second one would be, what role do students actually take after graduation? So I guess I am a live example of falling in love with infrastructure, falling in love with the civil engineering that is involved in actually delivering Hyperloop, and rather than going off and working in finance, which my degree put me to do. I stayed within infrastructure and co-founded a startup, and I guess many of you maybe already have such ideas or know someone who's done a similar thing or not. But essentially, what do you as students can do after you graduate? It's an open question. And maybe some of you already have ideas what you're going to be doing after you graduate.
Yeah,
Anyone
we
wants to
just
share?
put people on the spot when there's no hands raised.
Just to start a discussion, do you have any ideas how you stay?
At the moment, I'm not quite sure what I'm going to do after I graduate, but I'll definitely take all the things I've learned so far, working on Hyperloop, but also from other teams from these events, to become a better engineer and definitely help shape the future in some way or other. And who knows, it will be at a Hyperloop company or maybe something else, but to be honest, I'm not sure right now.
Thank you. Anybody else?
Stella there.
Yeah.
Thank you. So I will say something not very common here, but I am not an engineer. I am a mathematical physics student. But what I think the beauty of what we're doing here is that it's applicable to many, many things. What we're learning is not just Hyperloop, it is engineering, it is project management, it is how to complete a project with a deadline on time. It is how to work in a team, how to lead a team for some of us. And all of these things can then be brought into whatever we do later on. And it might not be directly Hyperloop, but it will be something else. Or it might even be something that helps Hyperloop become a reality. If someone works on a better technology for solar panels or transferring energy from the infrastructure to the pod, yes, maybe it's not a Hyperloop company, but it is still something that is there and helpful.
Thank you. So, Eva?
I have quite a straightforward answer to the question because I'm graduating this year, so I know what I'm going to be doing. And I think being in Hyperloop related team really sparked interest in sustainability, so I know I'll be doing not something very related in the sense that it won't be Hyperloop related, but it is renewable energy. So it is working with wind turbines, wind energy, and it is all connected, all about changing the world for the better and trying to make the world more sustainable.
Thank you. Maybe, Carolina, you can go with the next question.
Yeah, so that actually ties in nicely with what are the benefits during the journey. And again, looking at students who've been to the SpaceX competition and graduated earlier, they wanted to continue on this independent path. And another example, which you might have heard of, is Continuum Industries, which is another startup solely funded by hyped students. And they've actually realized that in order to deliver Hyperloop or any other linear project, it takes a lot of design time. And Michele opened up the the problems that are associated with certification, but there is also design of the route itself, passing through topography. And they've realized that the current design industry is massively inefficient and actually produced a very smart optimization platform and now are scaling it up. So throughout the journey with Hyperloop, we've identified how existing industries could be made better, where the efficiencies are, and how we can, with the different skill set, actually capture it. Did you perhaps, in your time, identify any such inefficiencies that exist? Maybe a specific part of the system, maybe a specific process that is inefficient in current ways of going about things, whether that's design, delivery, or anything? Can you think of anything? Again, putting on the spot. But
No problem. Otherwise, I can put you on the spot, Carolina, because you for sure found something that you're currently working on.
yeah, absolutely. I mean, while designing I think, it was the second iteration of our pod, we just kept on being fascinated by magnets, by the Hallbeck arrays, and wanted to do something cool with it. And this is essentially how the idea for our bolt-on device emerged. And we found that having the label of Hyperloop actually not only gave us the initial easiness in delivering the elevator pitch to gather someone's interest, but it was also really helpful in terms of actually the network of supervisors and other students that you know, in terms of actually people you share ideas with, but also people who will accompany on your journey, whether here or actually beyond. So you're in a fantastic position, and do speak to each other, and do take it forward, the capital that you've accumulated now.
Thank you. And actually that brings us to point number 6. We went through a bit quickly, also cautious of time. Please stand up if you think that for 750 billion we will be able to build a network connecting Europe with Hyperloop. There's always maybe options, and I think that in all fairness, there's no right or wrong. We are on a journey, and although in the reports and in your reports we see a lot of cost figures, they change daily. Construction costs go up, value of money changes, and things like that happen. But I think it's a good initiative to keep thinking about what are the costs of Hyperloop, and how can we make it comparable with others. You might remember that during one of the virtual sessions we had the question about prices of airplane tickets or train tickets compared to Hyperloop. And I think that with this initiative of the European Union to price CO2 as a cost factor into everything we do, Hyperloop is becoming more feasible. And in the end, it's not about the cost of investing, it's about the return on investment. And it's all about making sure that when you calculate this, it's not only about money. It's about sustainability, it's about the social economic effects. It's about us, all of us, just making sure that we have the right way of transportation, connecting the way we like to have. And I think that is really the journey we're all in. So no wrong answer or right answer, I think always a good answer. Standing here, also on behalf of Michele and Kwar, I think we would like to ask you all, and not the people actually organizing European Hyperloop Week, but all the others, to give a big applause actually to the team of Valencia and other people involved in European Hyperloop Week. Because I think, and together with me, the whole team, the whole jury group thinks that you did a tremendous job of just getting us together here. It's already making connections between the jury groups, within the jury groups, and hopefully also between the teams. Because that's what we need to get to the next level of Hyperloop. Thank you.
One quick question. Does anyone have any questions for the AECOM team? Okay, you can command them to them anytime. They're going to be staying around here, so you can just go up to them and ask them.
Miguel, ¿podemos usar otro ordenador con el cable? So you manage better than here you have the and which type of micro do you prefer? This one?
Yeah, this one's more convenient.
Yeah. Okay. Have to put it down. Try to stick.